The automotive world has just witnessed a seismic shift, one that redefines what electric vehicles are capable of. Tesla's latest breakthrough isn't just an incremental upgrade, but a declaration of technological dominance. Elon Musk has once again defied expectations, unveiling an electric motor so advanced that industry experts are calling it a glimpse into the future of transportation. This isn't merely another step in the evolution of EVs, it's a quantum leap. A disruption so profound that it could render competing technologies obsolete before they even catch up. At the heart of this revolution is Tesla's carbon-wrapped rotor, a deceptively simple innovation that solves some of the most persistent challenges in electric motor design. Traditional motors rely on metal components that expand, warp, and degrade under extreme conditions, imposing hard limits on speed, efficiency, and longevity. Tesla's solution replaces these limitations with a carbon fiber reinforced rotor, a material so resilient that it remains stable even at previously unthinkable rotational speeds, exceeding 20,000 RPM. Where conventional high-performance electric motors falter beyond 16,000 RPM, Tesla's design not only endures but thrives, delivering unprecedented power without the usual trade-offs. The implications are staggering. This motor is faster, lighter, and more energy efficient than anything else on the market, redefining the boundaries of acceleration, range, and durability. But the real genius lies in its simplicity. By reducing reliance on rare earth metals and minimizing moving parts, Tesla has made this motor easier and cheaper to manufacture at scale. While legacy automakers struggle to retool decades-old production lines for electric drivetrains, Tesla's vertically integrated factories are already optimized for this next-generation technology. The result is a performance envelope that borders on the surreal, 0 to 60 in under 2 seconds, outpacing multi-million-dollar hypercars while sipping energy rather than guzzling it. Unlike traditional high-performance EVs that sacrifice range for speed, Tesla's motor maintains efficiency even under extreme loads, eliminating the dreaded trade-off between power and practicality. Drivers no longer have to choose between exhilarating acceleration and the anxiety of a dwindling battery. This motor delivers both, seamlessly and reliably. Beyond raw speed, the motor's thermal efficiency is a game-changer. It runs cooler, lasts longer, and requires less energy to maintain peak performance, all while being cheaper to produce. This isn't just an engineering marvel, it's a strategic masterstroke, one that allows Tesla to undercut competitors on cost while outperforming them in every measurable metric. The timing couldn't be more devastating for rival automakers. Just as they were beginning to close the gap with their own EV offerings, Tesla has moved the goalposts yet again. Legacy manufacturers like Ford, GM, and Volkswagen are burdened by outdated platforms originally designed for internal combustion, forcing them to adapt rather than innovate. Their EVs are often heavier, less efficient, and more expensive to build, relying on third-party suppliers for critical components like batteries and power electronics. Tesla, by contrast, controls every aspect of its supply chain, from raw materials to final assembly, giving it an insurmountable advantage in both speed and cost efficiency. Even newer EV startups like Lucid and Rivian, despite their cutting-edge designs, lack Tesla's manufacturing scale and vertical integration, leaving them vulnerable to production bottlenecks. Lucid's Air sedan may rival Tesla in luxury and performance, but its limited production capacity and premium pricing prevent it from achieving mass-market impact. Rivian's rugged electric trucks have earned critical acclaim, but scaling up production has proven far more difficult than anticipated, exposing the challenges of competing with Tesla's industrial might. Meanwhile, Chinese automaker BYD, though leading in global EV sales volume, primarily competes in the budget segment, leaving the high-performance and high-tech markets firmly in Tesla's grasp. But the motor is only part of the equation. Tesla's true dominance stems from its integration of hardware, software, and energy systems into a seamless ecosystem. The 4680 battery cell, designed in tandem with this new motor, offers greater energy density, faster charging, and improved longevity, further extending Tesla's lead. Unlike competitors who rely on standardized battery formats, Tesla's in-house cell design is optimized specifically for its vehicles, maximizing efficiency and minimizing waste. This synergy between motor and battery creates a powertrain that is not only more powerful but also more sustainable, reducing reliance on scarce materials and lowering production costs. Yet even this pales in comparison to Tesla's most formidable advantage: its artificial, intelligence-driven full self-driving (FSD) system. While other automakers depend on pre-mapped routes and LiDAR sensors, Tesla's AI learns from billions of real-world miles driven by its global fleet, constantly improving through machine learning. Every Tesla on the road acts as a data-gathering node, feeding real-time information back into the neural network, refining its algorithms with every passing mile. This creates a self-reinforcing loop. The more Teslas there are, the smarter the system becomes, widening the gap between Tesla and competitors who lack this vast data pipeline. The implications extend far beyond autonomous driving. Tesla's AI optimizes energy consumption, predicts maintenance needs, and even enhances safety in ways that static engineering cannot. When combined with the new motor and battery, the result is a vehicle that doesn't just outperform the competition, it outthinks them, evolving over time through software updates. While rivals struggle to match Tesla's hardware, they face an even steeper challenge in replicating its software ecosystem, which has become almost as formidable as its manufacturing prowess. Tesla's factories, meanwhile, are evolving at a pace that leaves traditional automakers struggling to keep up. Gigafactories in Shanghai, Berlin, and Texas are models of automation. These facilities leverage robotics, AI-driven logistics, and vertical integration to produce vehicles faster, cheaper, and with fewer defects than conventional assembly plants. In Europe, Tesla's Berlin Gigafactory has disrupted the automotive heartland, forcing established brands like Volkswagen and BMW to accelerate their own EV plans or risk obsolescence. In China, Tesla dominates the premium EV market despite fierce local competition, proving that its brand and technology transcend regional barriers. And with expansions into India, South America, and the Middle East already underway, Tesla is positioning itself as the first truly global electric car company. Its direct-to-consumer sales model eliminates dealership markups and middlemen, allowing for faster adoption and greater control over the customer experience. Unlike legacy automakers shackled by franchise laws and outdated distribution networks, Tesla can update its vehicles over the air, deploy new features instantly, and respond to market shifts with agility. This isn't just a car company, it's a vertically integrated technology platform, one that encompasses energy generation, storage, and mobility in a single, self-reinforcing loop. Solar roofs and Powerwall batteries integrate with Tesla vehicles to create decentralized energy ecosystems, reducing reliance on the grid and fossil fuels. The company's ambitions extend beyond personal transportation. Tesla's Semi, Cybertruck, and future robotaxis hint at a future where its technology underpins entire logistics networks. Elon Musk's vision isn't limited to making better cars, it's about redefining humanity's relationship with energy and transportation on a planetary scale. The new motor, then, is not an endpoint but a catalyst, the foundation of a broader strategy that aims to make Tesla synonymous with sustainable energy and AI-driven mobility. For competitors, the challenge is no longer just catching up to Tesla's current technology, it's anticipating where the company will go next, a task that grows more daunting with each breakthrough. The carbon-wrapped rotor is a warning, a signal that Tesla's lead is widening, not shrinking, and that the future of transportation is being written on its terms. As the automotive industry grapples with Tesla's latest disruption, the broader implications of its carbon-wrapped motor are coming into sharp focus. This isn't just about better cars, but about rewriting the rules of the entire transportation sector. The motor's efficiency gains ripple outward, influencing everything from battery lifespan to charging infrastructure, further entrenching Tesla's position as the undisputed leader in electrification. Where competitors see incremental improvements, Tesla sees systemic reinvention. Each innovation is designed not in isolation but as part of a holistic vision where every component amplifies the others. This interconnected approach is why Tesla's advancements are so difficult to replicate. It's not just about building a better motor, but about reimagining the entire vehicle around it. Traditional automakers, constrained by legacy architectures, must retrofit electric drivetrains into platforms originally designed for gasoline engines, resulting in compromises that Tesla simply doesn't face. Tesla's vehicles, by contrast, are engineered from the ground up as integrated systems where the motor, battery, software, and chassis are optimized in unison. This allows for weight savings, aerodynamic refinements, and thermal management solutions that legacy manufacturers can't match without starting from scratch. The carbon-wrapped rotor exemplifies this philosophy. By reducing heat and friction, it not only boosts performance but also lessens the strain on the battery, extending its usable life. This creates a virtuous cycle. Longer battery life means lower total cost of ownership, which accelerates consumer adoption and strengthens Tesla's market position. Meanwhile, competitors face a brutal dilemma: either invest billions in developing their own bespoke EV platforms, a process that takes years, or continue lagging behind with stopgap solutions. Even those who attempt to emulate Tesla's vertical integration find themselves hamstrung by supply chain dependencies, particularly in battery production. While Tesla secures lithium, nickel, and cobalt through direct mining partnerships and refines its own materials, most automakers remain at the mercy of external suppliers. This vulnerability was exposed during recent supply chain crises, where Tesla's agility allowed it to navigate shortages while rivals faced production halts. The 4680 battery, with its tabless design and dry electrode process, further widens this gap. It's not just more advanced, but also cheaper and faster to manufacture. Tesla's factories can produce these batteries at unprecedented scale, ensuring that its vehicles remain both high-performance and high-margin, a combination competitors struggle to achieve. This financial advantage fuels Tesla's relentless R&D, creating a feedback loop where each breakthrough funds the next, leaving rivals perpetually playing catch-up. The company's lead in artificial intelligence compounds this effect. While others treat autonomy as a future goal, Tesla's FSD system is already learning from millions of real-world drivers. This data advantage is insurmountable in the short term. No competitor has access to the sheer volume of driving scenarios that Tesla's neural networks train on daily. As a result, every update to FSD makes Tesla's cars smarter, safer, and more valuable, creating a software moat that complements its hardware superiority. This dual dominance in both physical and digital realms positions Tesla not just as a car company, but as a mobility platform akin to Apple's iOS or Google's Android. Owners aren't just buying a vehicle, they're buying into an ecosystem that improves over time, a concept foreign to traditional automakers still selling static products. Tesla's over-the-air updates mean that a car purchased today will gain new features years later, enhancing resale value and customer loyalty in ways competitors can't match. This software-defined approach is reshaping consumer expectations. Soon, buyers will demand the same continuous improvement from all automakers, a shift many are ill-prepared to handle. Meanwhile, Tesla's global manufacturing footprint is expanding with a speed and precision that mirrors its technological ambitions. The Shanghai Gigafactory, built in a record-breaking 168 days, now exports vehicles to Europe and Asia, demonstrating Tesla's ability to localize production and evade trade barriers. Berlin's factory, despite regulatory hurdles, has become a showcase of sustainable manufacturing, with water recycling and on-site battery production setting new industry standards. Texas's Gigafactory, home to the Cybertruck, is pioneering megacasting techniques that reduce vehicle complexity by molding large sections of the chassis as single pieces. These factories aren't just production sites, they're laboratories for industrial innovation, where Tesla refines processes that competitors won't adopt for years. This global network also insulates Tesla from regional disruptions. When one factory faces challenges, others can compensate, ensuring uninterrupted supply in a volatile world. Simultaneously, Tesla is redefining sales and service. Its direct-to-consumer model bypasses dealerships, eliminating markup and creating a seamless digital purchasing experience. Service centers are increasingly redundant as remote diagnostics and mobile repair units handle most issues, reducing overhead and increasing customer satisfaction. This lean distribution model allows Tesla to operate with margins that traditional automakers, burdened by franchise laws and bloated inventories, can only envy. Financially, Tesla's profitability enables aggressive reinvestment. While legacy automakers divert EV profits to subsidize declining ICE divisions, Tesla pours every dollar into growth. This divergence is creating a split in the industry. Tesla and a handful of nimble rivals accelerating into an electric future, while others remain tethered to the past. The carbon-wrapped motor, then, is more than a product. It's a symbol of Tesla's broader strategy: identify industry pain points, engineer radical solutions, and scale them faster than competitors can react. Elon Musk's ultimate vision extends beyond cars. Tesla energy, solar, and storage solutions are positioning the company as a full-spectrum energy provider. Powerwalls and megapacks integrate with EVs to create decentralized microgrids, reducing reliance on utilities and fossil fuels while enhancing resilience. This convergence of transport and energy hints at a future where Tesla vehicles aren't just consumers of electricity but active participants in a smart, renewable grid. The semi and Cybertruck will disrupt freight and construction, sectors ripe for electrification but ignored by legacy automakers wedded to outdated business models. Robotaxis, once regulatory hurdles clear, could render personal car ownership obsolete in urban areas, with Tesla earning recurring revenue from autonomous fleets. In this context, the new motor isn't just about winning the present EV race, it's about laying the groundwork for Tesla's next act as a provider of mobility as a service. Competitors, meanwhile, face existential questions. Can they transition quickly enough to survive, or will they follow Kodak and Blockbuster into obsolescence? Some, like Ford and Volkswagen, are betting billions on their own EV divisions, but their progress remains hampered by bureaucratic inertia and unionized workforces resistant to change. Others, particularly Japanese automakers, remain oddly committed to hybrids and hydrogen, technologies that Tesla has rendered irrelevant for most applications. Chinese firms like BYD and NIO pose a stronger challenge, but their focus on local markets and budget segments limits their global threat to Tesla's premium dominance. Startups like Rivian and Lucid, though innovative, lack the capital to compete in a price war, leaving Tesla free to undercut them as scale advantages kick in. The brutal truth is that Tesla's lead in technology, manufacturing, software, and energy integration is now so vast that catching up would require competitors to abandon decades of entrenched practices. Few seem willing or able to do so, ensuring that Tesla's trajectory will continue its upward arc while others scramble to adapt. The carbon-wrapped motor, then, isn't just another product milestone, it's the latest proof that Tesla isn't playing the same game as its rivals. Where they see electric vehicles as a replacement for gasoline cars, Tesla sees them as the first step toward a post-oil economy powered by AI and sustainable energy. This broader vision explains why Tesla's innovations seem to arrive faster than the industry can process them. Each breakthrough is part of a larger plan, meticulously executed. For consumers, this means better, cheaper, and more capable EVs. But for competitors, it's a relentless pressure that will force consolidation or collapse. The motor, then, is both a marvel of engineering and a strategic weapon, one that ensures Tesla's dominance for years to come. Elon Musk's ultimate triumph may not be in making the best electric car, but in making competing visions of the future seem obsolete before they even arrive. The race isn't over, it's just become clear that Tesla is the only one running at full speed.